Yeah, hello, welcome to my talk, Proactive Performance Analysis in Postgres. My name is Dirk Krautschik, and some words about me. I'm working with Trivadis for a little bit more than 3 years now. I'm doing Oracle and now mostly Postgres topics as a consultant and a trainer. And I actually have 14 years of experience in this particular uh, areas, and yeah, some private words about myself if you are interested. Some words about my company. Trivadis actually is become a part of Accenture now, and that's basically the same situation like before. We are doing consultant and services about data and AI solutions. And if you're interested more in this particular topics, just ask me after the talk. I don't want to make so much commercial part in this because we have less time. Okay, let's get through to the talk. The performance problem. I think here in the audience there will be a lot of DPAs, and they will know that performance problems are a very important task, a daily task of DPAs. And if you have experience with performance problems, you will know that there will be a lot of variant problems described by users. So that is always a challenging task, and it's also challenging to get the the right information for the problem description. For example, like uh, basically what is exactly slow, and also when it was slow, and something like this. And also information what did happen before or during the performance problems. That is always important information. It's sometimes hard to get. Um, the usual reasons for performance problems are, yeah, bad sizing in the beginning, some changes in the behavior of the database, maybe for different data diversification or changes in the application itself. There are also special reasons like maybe a new database release, upcoming new features, and so on. And that is basically the motivation for this talk. Migrations, when, for example, you did a migration from Oracle to Postgres, and then after that you have different performance situation like you are used with Oracle, for example. And why is that? The thing is that when you move from one database system to another, if you are not in the database field, you maybe expect that basically a SQL statement will behave basically the same like before, but that mostly isn't, because every database system has maybe different behaviors in like plan decisions, the use of indexes, and something like this. Another thing is when you are, especially when you move from Oracle to Postgres, the usual Oracle DBA is pretty much spoiled by the, to be honest, very good tooling for investigating a performance problem on Oracle database. In Oracle, you have this kind of Oracle Diagnostic and Tuning Pack with a lot of toolings, uh, doing a really good job searching for performance problems. And that is actually something out of the box you have not with Postgres. But in the beginning, how to prevent performance problems in the first place? The easy part is maybe do Kiwi, let's say kill it with iron or idle, just put more and more hardware, more and more resources on the servers, on the system. That could be, of course, a solution, but it is not efficient. Um, the better way is during a migration, you have to invest in a you have to invest more time in a detailed testing phase. And in this testing phase, it's very important to work as a team, in particular with development, with the application owner, the system engineers, and of course also the database administrators. My experience is that for political reasons, the migration projects um, are planned with not enough time during for this testing phase, and so the goal is just to do the migration, and at the end you will can run into performance problems after going live and whatsoever. And that is always a problem. And that is what we want to prevent in the first place. And of course, in Postgres, we don't have some kind of adaptive or autonomous blah, blah, blah features from Oracle. That is something we basically have not in Postgres yet. So what is the dilemma in this case? The dilemma is the system is currently slow. That's information, okay, we have to do something with it. But the worst problem is when the system was slow. So we have to investigate something what is happening in the past. So what about at the beginning, what is basically the analysis of a performance problem in the most granular way? The craftsmanship. The granular way of investigate a performance problem is just to find out which statement is slow. So you have to identify the problematic statement. Maybe it's a one-time problem. Maybe it's a problem always with the same statement, and you have to check what's going on there. So at the end, the problem has to be reproducible. So because the statement is already finished, it was slow, and now you have to check what happened. You have to check, are you able to check what happened, or do you have to reproduce the situation with this particular statement? Then you have also to check, is it time or data situation related? So is it something which happens all the time, or is it something it happens only on noon, for example? So at the end, when you have this situation and you want to find out which statement was slow, or you have a statement which is slow, you have to investigate. That is something like digging in the explain plans. So what is an explain plan for those who don't know? The explain plan is basically the description how Postgres, or let's say how every database system is proceeding SQL statement. So it's something as going as a result from an optimizer or query planner or whatsoever. Every relational database system has something like this, and it's based on statistics on the tables, it's based on settings, it's based on metadata, and related to this information, the database system will decide how to proceed with a statement. And that is something you can investigate in. So if you want to see an explain plan in Postgres, it's basically with the simple command explain and the related statement. In this case, in this example, you see a select statement, and you will get an estimated explain plan how Postgres is thinking to do this statement. It's not a run, it's just a dry run. So in this case, Postgres will just estimate and will do nothing. So that's only an estimation, so not that detailed we want to know. So if you want to have, let's say, a scenario, you want to reproduce an SQL statement, then the better way would be to do an explain analyze. Explain analyze will get to more results, more information, but in this case, the statement will run on the system. So that is something with selects, maybe not a problem, but if you want to do data changes or delete, update, whatsoever, that is something you cannot easily do on a production system, for example. You have a lot of options with the command explain, and it's always a good idea to check in the documentation about the several options, which is activated by default, what is possible in which particular Postgres version, because that is something which changed in the last versions. So you have that is the listing for the Postgres version 14, and you will not find every feature in lower versions, for example. So please check for this, and if you are able to get this information, just feel free to use it. And to have an example, you don't have to read it at this time. Just an example, an explain for the same statement you have seen before, just with every options activated in Postgres 14, you will get this kind of explain plan. So a lot more details, a lot more possibilities to investigate in. In this talk, I don't want to explain how to read an explain plan, how to investigate with an explain plan. I want to just show you how to get the information for the investigation in this case, because reading explain plans, working with explain plans is something you can fill full talks with. The thing is with explain plans is that reading explain plans could be really hard. That one is a really straightforward example. That's something you can work on, for example. But I have another example, just written in really small letters, but for example, to show you how hard explain plan could be. And there are a lot of more pages like this for this particular statement in my example. So reading explain plans could be really hard. It's difficult to investigate. You have to do it block wise, just get a part and work on it, and then go step by step. To make this more easy, I have a recommendation. If you have to investigate on explain plans, just feel free to use tools like this kind of websites. You can put an explain plan in. This example is from explain.dalibo.com. It's just a free website. You can put an explain plan in, and you will get a graphic uh, version of the explain plan. You can dig in this picture. You can zoom in. You can see some information more readable, let's say human readable. And it's not a blame to use something like this because it's 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 basically a time saver to work with this kind of tools. I would say in my experience in projects that had saved me days, let's say. So just to have this more readable, more human readable, to use this for documentations and so on. And this is an example like before. For the same example with the select statement in the explain analyze I used before, you see it like this, and you can just see all informations you have in the explain plans written down in a more human readable way. So you can just dig in, you can see some IOs and so on. Just it's a better way to investigate with this. What are the usual recognitions when you are investigating with explain plans? Most of the time, you will find out that you have not the optimal access methods. Maybe for using wrong in or missing index strategies. If you see something like that, you have full table scans. The classic result for investigation is you see full table scans, and you want to get rid of it. Maybe there's a missing index. There could also be that the SQL statement is poorly written, so that when you use a different way to write this SQL statement, the optimizer will decide on a better way. That is also something what we see a lot of time. And of course, the settings of the query planner could be affect the situation. You can configure in Postgres some parameters regarding the optimizer or the query planner, and that is something you have to keep in mind. What also could be a reason for slow performance or slow running queries is old or useless object statistics. You remember the optimizer or query planner decides for the explain plans based on table statistics. And for example, when these particular statistics are old or not actual or not matching the real situations, for example, you check for the statistics, you make an actual version of the statistics, and then you have a batch job changing everything in the table, and the statistics are still the same with the old situation, then maybe the plan decisions will be different or not optimal. And of course, basically for Postgres in this case, the configuration of auto vacuum settings could also be a big thing regarding the performance analysis. That is basically the granular way to investigate. But this talk is about getting proactive. So how to get proactive? First of all, sizing. Sizing is pretty much important with Postgres, because when you have installed Postgres out of the box, you will have seen that the standard parameters are pretty lightweight. So you see here, shared buffer is basically 128 megabytes. That is quite low. So it's important, and that sounds funny, but I have seen customers just running with default settings, and they are wondering about why is it running so slow. So that is something I want to tell you here. It's important to frequently review the configuration. So just check what is the setting in the actual database, see, and please use realistic sizings and for the database. Another thing is what I recognize is, also what I often recognize at customer sites is that the parallelization is not used at all. So I find servers running only a Postgres cluster with whatsoever 64 cores, and they are just running with the default parameters. So they could use the other cores more in a more efficient way if you give Postgres the ability to do parallelization. Just switch off. Sorry, not switch off. Just increase the parallel workers and so on, and make it possible that Postgres can decide to run queries more parallelized. So that is something. It is not a guarantee that everything will get faster with parallelization, but there's a good chance that you will have better results with when you have a server with a lot of cores and you are actually using it. If you are not sure about the right configuration in the first place, also here it's not a blame to use tools like pgtune or from CyberTaxi configurator here. That's just two examples where you can just set with switches or with some rules. You can set the server configuration, and you will get a best practice configuration in the first place, which you can start with. So that is something I recommend to not so experienced customers with Postgres in the first place, so they can check about a good initial configuration. So that is something it's often very helpful, and you can optimize it or you can tune it later on for sure. But to start with, that could be a helpful tool in this case. So the idea of getting proactive is basically the best way is to recognize the performance problem before the user does. So maybe you are just checking the database and see, oh, the statements running low. The customer has not experienced it at the moment, but there will be something like this coming up when the customer starting to recognize that the system is reacting lower and lower. There's also the idea to having the possibility to check past performance problems. So that is something Postgres does not in out of the box. So if you want to see what's happening yesterday, you have to use additional tools or extensions for this. So you need basically permanent tracking of statement details. You may want to have the explain plans before, or you don't want to use an explain analyze after the problem. You want to just see the explain plan all the time. You want to have load statistics, and at the end, you don't want to make any reproduction situation. So you don't want to go to the customer, the user, to say, okay, do it again. I want to check. Do it again. I want to check. That is something end users don't want to hear. And yeah, first of all, maybe you're coming up with what is about monitoring. Yes, monitoring is maybe one way to check for this, but most of the monitoring tools are don't give you the right information. They are basically showing you the fact that's slow and not what exactly is slow. So if you want to do monitoring for Postgres and want to have a helpful monitoring investigating real performance problems, you should have monitoring tools which are able to look in the Postgres insights, for example, in the pgstat views and so on. So that is something you have to keep in mind. There are some cool tools like pgtop or the PG activity tool. You can just activate. It's helpful, but at the end, it's not a real monitoring solution. One example, don't want to make commercial here, just one good example to have a monitoring tool uh, just using for performance analytics and having a lot of process insights would be from Cybertech, the PG Watch monitoring solution. It's free to use, so that is something I just want to show you as a good example. But there are several more. That is just one example, which what kind of monitoring you can use to have more Postgres insights, right? So that's monitoring. But at the end, monitoring is not the right solution to investigate performance problems like I experienced in the past. The second thing is what is about the logging at Postgres. Postgres is able to do an exhaustive logging. So you can activate, you can basically log everything in Postgres. And so you are basically able to have all information to investigate everything. But yeah, the configuration is quite easy. You can just go in the configuration, just activate everything and do the log level upwards. But you will expect some large log files then on the system, and the handling of those log files is quite hard. So it's maybe something for a particular time. Maybe, for example, creating a script, activating the loggings, and just deactivate later on or something like this. But for a full-time running system in a production to activate every logging, you just expect to need sometimes. Maybe it does not make sense because the log files are too big later on. So that is maybe a solution, but not the best solution for getting to doing this proactive performance analytics. Also in the logging, you are able, I told you that maybe you want to see the explained plan immediately when you run a statement. There is the possibility to activate auto explain. That's basically a module you can just activate in Postgres, and then you are able to um, to to write in the log files every explain plan for every statement. Or maybe you can also use an and threshold, for example, just give me the explain plan in a log file for SQL statements running more than 3 seconds, like in this example. That is maybe a compromise for using logging, and you want to have the explain plans, but at the end, that will also lead to heavy loaded log files. You know, that's something also you keep in mind. So keep an eye on the storage and the maintenance of the log files and everything like this. But if you want to use the log files for analytics, another recommendation is to use PG Badger. It's an open source tool, just creating really nice reports out of the log files. And you can do it incremental, you can do it cumulative, just to get, put in the log files, getting a nice report, and web-based report like this picture here. And then you can use this to discuss with developers or something like this. That is something I'm used to make in projects that I create those kind of reports and go to the developers from the application and just discuss the behavior of the database, the load on the database, and make sure to optimize, to do a preventive investigation. Maybe there could be in the future be a performance problem because we have a lot of load in the middle of the night or something like this, and maybe in a few months or a few years, that could be a problem because the data diversification and so on. That is a good, helpful tool I would recommend. That's all good. That's all fine. We need to know what exactly is going on. We need some kind of runtime data for overall statement. We need more. We need to know where's the waste of performance. And all this information is basically in the database, in the Postgres cluster. But it's sometimes it's hard to find, and most importantly, that is not so easy to keep because information are not saved in the database. They are deleted sometimes, so you have to keep it somewhere. And in this particular time, we need to use the power of extensibility. Postgres has a really nice possibility to use extensions, and basically for analysis of performance problems, extensions are essential for my The first extension I want to, maybe most of you will know, is pgstat statements. As for my opinion, an extension which should be activated by default in the database. What does pgstat statement do? Basically, it will collect an aggregate of each statement and will just check how long the statement is running, and making an average out of it, collecting some other information, and will keep it in a predefined way. So, for example, there's a kind of a ring buffer. They will keep, for example, I think the default is 5,000, and at the end, when the 5,000 are full, they will drop all other statements and will just collect, so that at least we see the last 5,000 statements collected in an aggregate way. You can increase these particular value in the configuration, so just 5,000 is the default. So you will just see a view afterwards. If you activate the extension, you will just have the view pgstat statement. And yeah, here is a few words about installing it. I just don't want to describe it. You can read it in the slides later. And you have a view pgstat statement. You can do a select on pgstat statements, and you will see the query, how often the query run, what was the total execution time, what was the average execution time, the max and the min execution time, all this kind of stuff. And with this information, you can do a lot of really quick investigations. Like, for example, that is a good statement I have to mention, just to compare over all statements the running time and see which statement has needed the most time on the database, for example. Here we have an example. I run some pgbench stuff on the database, and then you can simply see which kind of statement needed the most of the time. In this case, you will see maybe this update in the first place, the 63% of all the time basically collected by pgstat statement. But you will see also, okay, that this statement run 1,500 times, so maybe it's not the problem. But you see some copy commands in the third row. Maybe that could be a problem, because 6% for just one run, that could be a performance, or that could be worth investigating, for example. So that is the way you can investigate in a database. That is also be possible to do proactive. You can just see which kind of statement was need this particular time. So that is the basic of all investigation. So that kind of statement I run 99% of all problems I will facing in the future and in the past. So the second way to investigate is, for example, I had a customer. The customer did a migration from Oracle to Postgres already, so that wasn't my job. So I just came in the project, and they said to me, "Oh, we have a performance problem. It was running about a few minutes in Oracle, and now it takes more than 50 minutes, this particular statement." That was luckily a benchmark statement, so I was able to just reproduce the scenario. But the thing was, the customer was pretty far away with investigation, so they activated the auto explain. They looked in the log files and see, oh, look here, there are indexes not used in Postgres, but actually used in Oracle. So why is that? Maybe there are missing indexes, and they had a lot of full table scans. I was quite impressed by the how far the customer went in the case. So it was it was cool that the customer was interested in this, and I was just starting digging in the plans again. That was kind of this statement, and to have more fun, it was an insert. So that is actually the large explain plan you have seen before, or the part of the explain plan you have seen before. So a really large explain plan I had to investigate, and I started to look at it and to see, and then I was thinking about, yeah, but that's something I don't think there should be more easy. So I thought, where's the waste of time? So I started to use pg weight sampling. What is pg weight sampling doing? Actually, you know that there are some these so-called wait events in Postgres and for example, in Oracle as well. And you can just check in the pgset activity view each session which kind of wait event is actually related to this particular session. So you are able to see what is when Postgres is not doing anything, why is that? So, and when you collect this information with a timestamp, with the query ID, with the session ID, with the PID, and so on, then we will be able to check every time why was something slow and why is the waste of time in this case. So that's actually what PG-weight sampling is doing. So here are some installation advice. I just want to switch. You can read it in the slides. It's just an easy installation. In this case, you think you don't have to compile it. In some repositories, it's available, and then you get a view, basically the same like pg-start statements, where you can see the wait event with the timestamp, with the query ID, and so on. And then you have a second view called pg-weight sampling profile, where you can see the aggregate collections of each wait event based on a query, based on the session. And yeah, I just checked for it in this example. And that's an example, but it was nearly the same situation. I just checked for the session with where my tests were running, and I see a lot of wait events: buffer file write, buffer file read. And yeah, when the buffer file write and buffer file read is high, you can imagine that is about writing temp files on the storage. And writing temp files is Postgres doing because the work mem is maybe not configured correctly or not high enough. And it was basically that the situation. The work mem was set by default, and now remember the sizing situation. Just getting a configuration and not size it correctly. So I just increased the work mem, and tada! The statement was running from, I think, yeah, this I've written down here, 15 minutes to 3 minutes now. So that was it. So the 3 minutes was the expected time. I could have spent days in reading the explain plan. Maybe I have found something. Maybe I would be able to optimize the statement as well. There are maybe you've seen the explain plan. There are a lot of potential to get more performance out of it, but that was basically the result the customer expected. And I just want to see, just want to show how to find it out, not investigating in the statement base, more in the weight in the cluster base. Just to see why is something waiting, where's the wasted performance. That's basically the other way around to find out what's going on. So that is the both sides of investigation, the statements and the cluster side, right? And now you want to have, for example, you're collecting data and you're collecting with pg-start statements and pg-weight sampling, and now you want to have it more like, that is basically pointing to Oracle DBAs, because they just want to have the situation. For example, a customer is blaming about a performance problem in the past, maybe for example yesterday noon, and you want to check the situation in this particular time window. Then you can use another extension, PG Profile, which is maybe some Oracle DBAs will recognize it as a similar situation like like StatsPack or AWR in Oracle. It's basically a repository where Postgres is collecting snapshots from the situation in the database and the pg-start statements, and a few extensions like pg-start car cache. And you are able to create reports out of these particular snapshots. So if you want to say you want to have the situation yesterday noon, then you create a report based on the snapshot from 12 to 1 o'clock, for example, and you will get a report like this. It's a web-based report with all informations, with listing which statement was running fast and slow and so on, what was the waste of time, and everything like this. The wait events are still missing in this report. That is something I think it's in development. So when you see some in a GitHub comments, there is some idea about including wait events also in this kind of reports, but it's not in there yet, I guess. But that is if you have the possibility to add to maintain a repository database. For this, you need, of course, somewhere in a repository to collect the data. Then that is the most helpful way to investigate performance problems in the past, and and especially to get a good readable report out of it. So that is highly recommended. But in this case, it's sometimes not possible because you have to add a new database and so on. What's also nice is you can also do a comparison. So you can just create a report from yesterday noon, 12 to 1 o'clock, and today, 12 to 1 o'clock, and you will get one report with both situations next to each other. So you can just compare why was it yesterday slow and why is it today not, for example. So that is something really highly recommended. You need pgstat statements for this extension. And for example, pgstat car cache is not mandatory, but it's helpful if needed. Yeah, like I said, the PG weight sampling inclusion is pending at the moment. But I hope that will be also included. That then this tool would be nearly perfect for me at least. When I'm using it for investigating performance problems. In the matter of time, there's another additional extension I mentioned before, pgstat car cache, but I just want to skip it. It's basically the same like pgstat statements for more the storage reads and so on to investigate on this. So if you need this, that will be also an example to have this. So what is my strategy at the end? So to being proactive, I try to make sure that on all systems I've facing that pgstat statements is installed by default, and maybe pg weight sampling as well. The problem with pg weight sampling is that it's not part of the control package. That is sometimes you have to discuss, or sometimes you will not find in for example, in cloud environments, if you want to have, if you are using RDS in Amazon, you can get pgstat statements, but you can get PG weight sampling, unfortunately. So, but to do the activation, at least with the default configuration, is quite helpful, because later on it's difficult to add this extension, because for pgstat statements and weight sampling, you need to restart the cluster at least one time, because you have to do a parameter change. And if you have a production environment and you want to investigate and you have not a pre-installed extension like this, then you have the problem. Yeah, you need to make a change request, and you want to have the downtime, and you have to restart the cluster and everything like this. Maybe you have discussion with the architect and so on. So it's important to have this kind of extensions being prepared in the first place, and in the first installation phases and so on. The consider the use of PG profile is an additional thing, I guess. It's when it's possible, I try to use it. I try to install it, but I can understand when customers are saying, okay, we don't want to have additional databases in place. We don't want to use we don't want to maintain some other toolings like this. Then I'm okay with it when at least I have pgstat statements and weight sampling in place, so I can live with that. But if it's possible, it's helpful, and it's getting better results, of course. Then, of course, being prepared, like reviewing the logging settings. No? So at least you should have a good logging which helps you through the day, and you get a lot of information. You can log statements running more than a chosen time. For example, if you want to check for statements running more than 30 seconds, for example, you can write down a log files. That is some compromise you can do. But in the end, if you are working with logging, it's important to keep an eye on the storage, of course. If you want to do it like me, you can create scripts activating some loggings and deactivating later on. That is some thing I did in the past, but that is also just a workaround for using other tools. When you are using loggings, and consider, of course, the analytics with PG Badger. That is really, really cool because you get nice reports. That are reports you can give developers to look with you together on it. That is really efficient to have this kind of graphical version of the logging situation. When you are making proactive performance analysis, it's important to always check what makes more sense in this case. You know, like I explained in the example with the PG weight sampling, with the work mem situation, just get a feeling about, is it something I do on an SQL basis, just checking for the statement, or is it something I have to check on the cluster basis? For example, checking the configuration, see where the weights are going, and so on. What's also important is it's important to do a prevention check. Maybe if even when it's not reported by a customer or a user, just use pgstat statements to see, at least with the statement I mentioned before, are there statements running quite long, or are there statements need a lot of time in the database? Maybe you can do some pre-checks. It's one SQL statement. I've seen it's not that you had to spend hours working this out. It's just to see, there are some statements running long and so on. Check the possibility to make a SQL rewrite or doing changes in the indexes. It's not also always possible because if you have legacy software, of course, but that is something you have to keep in mind. You have to check the application behavior because that is something it could change with new versions and everything like this. And you have to evaluate the collection of the object statistics. And that is basically the settings of auto vacuum, for example, or the thresholds you have configured in the configuration. That is also important to start with. Yeah, some final words. That is just a roundup of my experience in investigating performance problems and using extensions, getting into projects and having this kind of situations. It's important to make your life as easy as possible. So that is why I say just pre-install these extensions and so on. Don't overmeasure. If you have a database running perfect all the time, and there's sometimes maybe a rare situation, you don't have to activate a lot of toolings because it doesn't make sense. And also here, like the example, don't focus on only one potential error. So when I just investigating the explain plans of this particular statement, I think I'm not finished yet. I wouldn't be finished yet because it was really a few pages of explain plan. Take the longest hanging fruits, just check for the statements are really slow, start with them over and so on. And of course, use extensions. There are maybe a lot of other extensions out there, really helpful, and that is something you have to keep in mind. So yeah, okay, that's basically it. I think I'm available for questions, and yeah, thanks for your attention.